Look up at the night sky, what do you see? A canvas of darkness, punctuated by countless points of light. Each one of those twinkling stars has a story to tell, a history that spans billions of years. Each twinkling point of light represents a sun, a massive ball of burning gas, radiating energy across the cosmos. And around many of these suns there are planets, perhaps with their own moons, forming intricate systems that dance in the vastness of space. What if, by the year 2100, humanity is no longer bound to Earth? Imagine a future where we have the technology to travel to these distant stars, to explore new worlds. What if we could journey to these distant worlds, not just as explorers, but as pioneers, seeking new homes among the stars? Picture cities on alien planets, bustling with life, a testament to human ingenuity and resilience. The universe is vast, filled with billions upon billions of galaxies. Each galaxy contains millions, if not billions of stars. Our own Milky Way is but one among them, a single galaxy in a sea of countless others. To think that we are alone in this cosmic expanse is to ignore the sheer scale of the universe. The possibilities are endless and the potential for discovery is boundless. Life in some form may be a common occurrence. Perhaps on some distant planet under a different sun, life has found a way to thrive. And if so, shouldn't humanity strive to become a multi-planetary species, a true citizen of the cosmos? Imagine the possibilities of a civilization that spans multiple worlds, each one contributing to the richness of human culture and knowledge. The year 2100 may seem far off, but a century is a mere blink of an eye in the grand timeline of the universe. In the span of 100 years, we have gone from the first powered flight to landing on the moon. Already our probes have ventured beyond the edges of our solar system, carrying with them the hopes and dreams of a species yearning to explore. These robotic explorers are the vanguard of our journey into the unknown. The desire to explore, to push beyond the known, is deeply ingrained in our DNA. From the earliest humans who ventured out of Africa to the astronauts who walked on the moon, exploration is a fundamental part of who we are. It is this spirit that will carry us to the stars. The drive to explore, to seek out new frontiers, will propel us forward into the vast unknown, where the universe of possibilities awaits. For millennia, humanity has clung to Earth, our pale blue dot in the vastness of space. This tiny speck, suspended in a sunbeam, has been our cradle, our home, and the stage for all of human history. From the earliest civilizations to the modern age, Earth has nurtured us, provided for us, and challenged us to grow. But what if, in the not-so-distant future, Earth becomes less of a center and more of a starting point? Imagine a time when our planet is just one of many hubs in a vast network of human activity spread across the cosmos. A time when the boundaries of our existence extend far beyond the confines of our atmosphere. What if, by 2100, we see the beginnings of a truly spacefaring civilization, with settlements scattered across our solar system and beyond? Picture colonies on Mars, thriving communities on the moons of Jupiter and Saturn, and even outposts on asteroids, each contributing to a new era of human exploration and expansion. Science fiction often portrays humanity colonizing distant planets, building sprawling cities beneath alien suns. These visions, once confined to the realm of imagination, are slowly inching closer to reality. The dream of interplanetary travel and extraterrestrial living is no longer just a fantasy, it's a goal within our reach. While the reality of 2100 may not be so grand, it's not beyond the realm of possibility. We may not have cities that rival those in our wildest sci-fi dreams, but we could have the foundations of a new way of life, one that sees humans as a multi-planetary species. Imagine a future where humans live and work on Mars, mining asteroids for resources, and establishing self-sustaining habitats. These pioneers would be the first to step beyond the cradle of Earth, forging a path for future generations to follow, and exploring the moons of Jupiter and Saturn. These distant worlds, with their unique environments and untapped resources, could become the next frontier for human exploration. The challenges would be immense, but so would the rewards. This isn't just fantasy, it's a potential future within our grasp. The technology needed to make these dreams a reality is already in development. From advanced propulsion systems to life support technologies, the building blocks of our spacefaring future are being assembled today. The key to unlocking this future lies in technological advancement. We need innovations that can overcome the vast distances and harsh conditions of space. Breakthroughs in propulsion, energy generation, and habitat construction will be crucial. We need faster, more efficient ways to travel through the vast distances of space. Current propulsion methods are too slow for interstellar travel, but new technologies like ion drives, nuclear propulsion, and even theoretical concepts like warp drives could revolutionize our ability to explore the cosmos. We need to develop sustainable ways to live and thrive in environments vastly different from our own. This means creating closed-loop life support systems, growing food in space, and finding ways to use local resources to build and maintain habitats. But most importantly, we need the will, the drive, the unwavering belief that a future among the stars is a future worth striving for. It will take the combined efforts of scientists, engineers, policymakers, and dreamers to turn this vision into reality. The journey will be long and challenging, but the destination, a thriving human presence beyond Earth, is a goal worth every effort. The challenges of interstellar travel are immense. The distances are staggering, measured not in miles but in light years. The distance light travels in a year. Conventional rockets, even at their fastest, would take tens of thousands of years to reach even the nearest stars. Clearly, we need a different approach. Enter the realm of advanced propulsion systems. Imagine harnessing the power of the stars themselves, using massive solar sails to ride on the pressure of starlight. Picture spacecraft propelled by fusion engines, generating energy by fusing atoms, mimicking the very processes that power the stars. These technologies are not merely the stuff of science fiction. Scientists and engineers around the world are already working on developing these concepts, pushing the boundaries of what's possible. Solar sails, for example, have already been tested in space, demonstrating the viability of this technology. The journey to the stars begins with a single step, and each technological breakthrough brings us closer to that goal. Section 4. From Dreams to Giant Leaps. Looking back at human history, we see a consistent pattern of innovation and progress. From the invention of the wheel to the development of the internet, each era has been marked by groundbreaking advancements that have reshaped our world. What was once considered impossible quickly becomes commonplace. Consider the telephone, once a marvel of communication, now an everyday tool we can't imagine living without. A century ago, the idea of humans walking on the moon was the stuff of fantasy. Science fiction writers and dreamers envisioned it, but few believed it would happen in their lifetimes. Yet in 1969, Neil Armstrong took that one small step, forever changing our perspective on humanity's place in the universe. His words, "That's one small step for man, one giant leap for mankind," echoed the sentiment of an entire generation. In even less time, we've gone from the first rudimentary computers, which filled entire rooms, to devices that fit in our pockets and connect us to a global network of information. These smartphones are not just communication tools, they are gateways to knowledge, entertainment, and social interaction. The pace of technological advancement is accelerating, and there's no reason to believe it will slow down. Innovations in artificial intelligence, biotechnology, and renewable energy are just a few areas where we are seeing rapid progress. If anything, it's likely to accelerate even further in the coming decades. Imagine a world where diseases are eradicated through genetic engineering, where clean energy powers our cities, and where artificial intelligence augments human capabilities in ways we can't yet fully comprehend. The dream of interstellar travel may seem daunting, but so did the dream of powered flight a mere century ago. The idea of humans flying was once relegated to myths and legends, yet today, air travel is a routine part of life. Just as the Wright brothers took to the skies at Kitty Hawk, future generations will pioneer new technologies, making the seemingly impossible a reality. Space exploration, once the domain of government agencies, is now being pursued by private companies with ambitious goals. The spirit of exploration, the drive to push beyond our limits, is what defines us as a species. From the depths of the oceans to the far reaches of space, our curiosity knows no bounds. It's what will ultimately carry us to the stars. As we continue to dream big and take giant leaps, we pave the way for future generations to explore new frontiers and achieve the unimaginable. Section 5. Warping Reality. The Alcubierre Drive. Perhaps the most intriguing and potentially revolutionary concept in interstellar travel is the Alcubierre Drive. Proposed by physicist Miguel Alcubierre in 1994, this theoretical drive doesn't defy the laws of physics but rather cleverly bends them. Imagine, instead of traveling through space, we warp space itself, creating a bubble around our spacecraft. This warp bubble would contract space in front of the spacecraft and expand it behind, effectively allowing the craft to ride on a wave of space-time. In theory, this could allow for faster-than-light travel without violating Einstein's theory of relativity. While still highly theoretical, the Alcubierre drive sparks the imagination and offers a tantalizing glimpse into the potential future of interstellar travel. The challenges of realizing the Alcubierre drive are immense. It would require manipulating vast amounts of energy, possibly even harnessing the elusive force of dark energy. However, the potential rewards are equally immense. The ability to warp space-time would revolutionize space travel, making the vast distances between stars. The cosmos beckons, calling us to explore its vast, uncharted territories. Billions of stars populate our galaxy, each one a beacon of light in the dark expanse of space. Each star, a sun, potentially hosting planets of its own, each with its own unique story to tell. Could there be other Earths out there? Other life forms? The possibility is thrilling, igniting our imagination and curiosity. It's a call to explore, to venture beyond our pale blue dot and set sail on the cosmic ocean, driven by the desire to discover the unknown. This is the dream of interstellar travel, a dream that could become reality by 2105, transforming science fiction into science fact. For centuries we've gazed at the stars, wondering about our place in the universe, pondering the mysteries that lie beyond our reach. We've sent probes to our neighboring planets, robotic emissaries to unveil their secrets, expanding our understanding of the cosmos. Yet, the vast interstellar gulf remains unconquered, a daunting challenge that tests the limits of our technology and imagination. Reaching another star system within a human lifetime presents immense technological challenges, requiring breakthroughs in propulsion, life support, and material science. But the human spirit thrives on challenges, driven by an insatiable curiosity and a relentless pursuit of knowledge. We are explorers, inventors, and dreamers, constantly pushing the boundaries of what is possible. And we are on the cusp of achieving what was once considered science fiction, turning dreams into reality with each passing day. Imagine a spacecraft, sleek and powerful, capable of traveling at a significant fraction of the speed of light, bridging the vast distances between stars. Picture a crew of intrepid explorers, embarking on a generations-long voyage to a new world, carrying the hopes and dreams of humanity with them. This is not merely a flight of fancy, it's a testament to the boundless potential of human ingenuity, a reflection of our unyielding spirit. The journey will be long, fraught with risks and uncertainties, but it is a journey worth undertaking. The rewards, the discoveries that await us, are beyond measure, promising to reshape our understanding of the universe and our place within it. The year 2105 may seem far off, but it's a mere heartbeat in cosmic terms, a blink of an eye in the grand timeline of the universe. Building an interstellar spacecraft is a monumental undertaking, requiring global cooperation and advancements in numerous scientific fields, from physics to engineering to biology. Yet the seeds of this endeavor are being sown today, in research labs and universities around the world, where brilliant minds are working tirelessly to turn this dream into reality. The quest for interstellar travel is not just about reaching the stars, it's about pushing the boundaries of human knowledge and pushing ourselves to achieve the seemingly impossible, to explore the unknown, and to expand the horizons of our existence. Building an interstellar spacecraft is a challenge of unprecedented scale. The complexity of such an endeavor requires the collaboration of the brightest minds in engineering, physics, and astronomy. Each component, from the propulsion system to the life support mechanisms, must be meticulously designed and tested. The distances involved are staggering. When we look up at the night sky, the stars seem so close, yet they are light years away, separated by vast expanses of empty space. Even the closest star system, Alpha Centauri, is 4.37 light-years away. This means that even if we could travel at the speed of light, it would still take over 4 years to reach it. To put that in perspective, light traveling at 186,000 miles per second takes over 4 years to traverse that distance. This is a speed that is currently beyond our technological capabilities. Conventional spacecraft, like the ones we have sent to explore our solar system, would take tens of thousands of years to reach even the nearest stars. This is simply not feasible for human exploration. Clearly, we need a revolutionary approach to propulsion. Traditional chemical rockets are not sufficient for interstellar travel. We must look to new and innovative technologies to bridge the vast distances between stars. One promising concept is the light sail, a spacecraft propelled by the momentum of photons, light particles from the sun or a powerful laser. This technology harnesses the power of light to push the spacecraft forward. Imagine a giant, reflective sail, thinner than a human hair, catching the faintest whisper of starlight and transforming it into motion. This sail would be incredibly lightweight and efficient, allowing it to accelerate gradually over time. With enough time, a light sail could reach a significant fraction of the speed of light, potentially shortening interstellar journeys to decades instead of millennia. This would make the dream of reaching other star systems within a human lifetime a real possibility. Another possibility is nuclear fusion, the same process that powers the stars. Fusion has the potential to provide a nearly limitless source of energy by fusing atomic nuclei together. By fusing atoms together, we can release enormous amounts of energy, far greater than anything achievable with chemical rockets. This energy could be used to propel a spacecraft at unprecedented speeds. A fusion-powered spacecraft could provide the sustained acceleration needed to reach incredible speeds. This would allow us to cover vast distances in a fraction of the time it would take with current technology. However, harnessing the power of fusion remains a formidable scientific and engineering challenge. The technology is still in its infancy and there are many hurdles to overcome before it can be used for space travel. Then there's the issue of navigation. Navigating through interstellar space is not as simple as plotting a course and setting off. The vast distances and the presence of interstellar matter make it a complex task. Interstellar space is not empty. It's filled with dust, gas, and microscopic particles that could pose a danger to a spacecraft traveling at high velocities. These particles, though tiny, can cause significant damage when encountered at high speeds. We'll need advanced shielding and navigation systems to ensure a safe journey. This includes developing materials that can withstand the impact of these particles and systems that can detect and avoid potential hazards. This will require sophisticated sensors, artificial intelligence, and real-time course correction capabilities. These technologies will need to work together seamlessly to navigate the spacecraft through the vast and unpredictable environment of interstellar space. Building an interstellar spacecraft is like constructing a miniature, self-sufficient world. It must support human life for extended periods, providing everything from air and water to food and medical care. It's a monumental engineering challenge that will push the limits of our technological prowess. Every system must be reliable and efficient, capable of operating autonomously for years or even decades. But with each obstacle we overcome, we move closer to realizing our dream of reaching the stars. The journey will be long and difficult, but the rewards, the knowledge, the possibilities, the future, are worth every effort. Together, we can turn the dream of interstellar travel into a reality. Imagine a vessel unlike any ever built. A ship that transcends the boundaries of our current technological capabilities and pushes the limits of human ingenuity. A marvel of engineering, housing generations of interstellar travelers. This vessel will be a floating city, a microcosm of Earth, carrying the hopes and dreams of humanity across the stars. This is no ordinary spaceship. It's a self-sustaining ark, designed to travel for decades, even centuries. It will be a beacon of human perseverance and adaptability, navigating the vast expanse of space. Its construction demands a delicate balance between strength, weight, and resource efficiency. Engineers must innovate with materials that are both lightweight and incredibly durable, capable of withstanding the harshest conditions of space. The ship's design must withstand the rigors of deep space, extreme temperatures, radiation, and the impact of micrometeoroids. Every component must be meticulously crafted to ensure the safety and longevity of the vessel. Shielding made from novel materials, perhaps even self-healing composites, will be crucial. These advanced materials will protect the ship and its inhabitants from the relentless dangers of the cosmos. Inside, a carefully calibrated ecosystem will provide breathable air, purify water, and grow food, mimicking the natural cycles of Earth. This closed-loop system will be essential for sustaining life on long-duration missions. Living spaces need to be more than functional. They must foster a sense of community and well-being. The psychological health of the crew is just as important as their physical health. Imagine spacious habitats bathed in artificial sunlight, hydroponic gardens bursting with fresh produce, and virtual reality environments that simulate the sights and sounds of Earth. These elements will help maintain a connection to our home planet and provide comfort in the vastness of space. Recreation areas, educational facilities, and cultural centers will be vital to maintain morale and intellectual curiosity on a journey that could span lifetimes. These spaces will nurture the minds and spirits of the crew, ensuring they remain engaged and motivated. The ship's crew will be more than just astronauts. They'll be farmers, engineers, teachers, artists, and storytellers. Each member will play a crucial role in the survival and success of the mission. They'll represent the diversity of humanity, carrying with them our collective knowledge, culture, and dreams. This diverse crew will be a testament to the strength and resilience of the human spirit. Their mission to reach a new world, establish a human presence among the stars, and continue our never-ending quest for exploration and discovery. This journey will be a monumental step in our evolution as a species. Building the interstellar ship is a feat of engineering, but it's also an act of imagination. It requires us to dream big and think beyond the confines of our current reality. It's about envisioning a future where humanity becomes a multi-planetary species, capable of navigating the vast cosmic ocean and establishing a permanent foothold among the stars. This vision drives us to innovate and push the boundaries of what is possible. It's about building not just a ship, but a legacy for future generations. A legacy that will inspire countless others to look to the stars and dream of what lies beyond. This interstellar voyage is not just a journey through space, but a journey of human ambition. The universe beckons. It is a call that resonates deep within the human spirit, a call that has echoed through the ages, urging us to look beyond our world and into the vast expanse of the cosmos. It calls to the explorer within us, the part of us that yearns to discover, to understand, and to experience the unknown. This call is not just a whisper, it is a powerful, unrelenting force that drives us to push the boundaries of what is possible. For millennia we have gazed at the stars filled with wonder and a thirst for discovery. Ancient astronomers with their rudimentary tools mapped the heavens and laid the groundwork for our understanding of the universe. Their curiosity and determination set the stage for the incredible advancements we see today. In 2115, that ancient yearning finds its fulfillment. Our cities are now hubs of advanced technology, and space travel has become a reality for many. The dreams of our ancestors are now within our grasp, and we are poised to take the next giant leap for mankind. Humanity stands on the cusp of a new era, one defined by interstellar travel and the boundless possibilities it holds. We are no longer confined to our home planet. The stars are now within our reach. This new era promises to be one of unprecedented exploration and discovery. We are driven by an insatiable curiosity, a desire to push the boundaries of knowledge and explore the unknown. Our scientists and engineers work tirelessly to develop the technologies that will take us further than we have ever gone before. Every mission, every discovery, brings us one step closer to understanding the mysteries of the universe. The cosmos, with its vastness and mystery, represents the ultimate frontier. It is a place of infinite possibilities where each star, each planet, holds the potential for new discoveries. The beauty and majesty of the universe inspire us to dream big and to reach for the stars. Our journey will not be easy, but the rewards promise to be immeasurable. The challenges we face in space are unlike any we have encountered before, but they are challenges we are prepared to meet. The establishment of space colonies and the discovery of new life forms are just the beginning of what we can achieve. We venture into the cosmos not just as explorers, but as pioneers seeking new homes, new knowledge, and perhaps even new life. Each step we take into the unknown is a step towards a brighter future for humanity. The potential for new discoveries and new beginnings is limitless. The spirit of exploration is deeply ingrained in our DNA. It is a part of who we are, a driving force that has propelled us forward throughout history. From the earliest explorers who crossed uncharted seas to the astronauts who first ventured into space, this spirit has been a constant in our journey. It is what drove our ancestors to cross oceans and conquer continents. Their courage and determination paved the way for the world we live in today. Now we stand on the brink of a new frontier, ready to continue their legacy and explore the cosmos. Now it compels us to reach for the stars. The same spirit that drove our ancestors to explore new lands now drives us to explore new worlds. The rockets that launch into space are not just machines, they are symbols of our unyielding desire to discover and to understand. In the year 2115, we stand ready to answer that call, to embark on the greatest adventure in human history. The journey ahead is filled with challenges and uncertainties, but it is also filled with promise and potential. Together we will explore the cosmos and unlock the secrets of the universe, forging a new path for future generations. For centuries, the vast distances between stars seemed insurmountable. The sheer scale of the universe with its billions of galaxies, each containing millions or even billions of stars, presented a daunting challenge for humanity. The idea of traveling to even the nearest star system seemed like a distant dream, far beyond our reach. The speed of light, once thought unbreakable, presented a seemingly impassable barrier. At approximately 299,792 kilometers per second, it set a cosmic speed limit that made interstellar travel appear impossible. Even at light speed, journeys to the nearest stars would take years, if not decades. However, the human spirit, fueled by ingenuity and a relentless pursuit of the impossible, has found a way. Scientists and engineers have dedicated their lives to overcoming these barriers, pushing the boundaries of what we thought was possible. Through countless hours of research, experimentation, and innovation, they have brought us closer to the stars. In the 22nd century, the dream of faster-than-light travel has become a reality. Our cities are now hubs of advanced technology, and our spacecraft are equipped with engines that can propel us beyond the confines of our solar system. The once impossible dream of exploring distant star systems is now within our grasp. The key lies in manipulating the very fabric of space-time. By understanding the intricate dance of gravity and the structure of the universe, we have unlocked the secrets of faster-than-light travel. This breakthrough has revolutionized our approach to space exploration. The theoretical concept of a warp drive, once relegated to the realm of science fiction, is now an engineering marvel. These engines, designed to create a warp bubble around the spacecraft, have transformed our ability to traverse the cosmos. The warp drive is no longer a figment of imagination but a tangible reality. By generating a localized distortion of space-time, our starships can effectively warp the space around them, creating a bubble that allows them to traverse vast cosmic distances in the blink of an eye. This warp bubble contracts space in front of the ship and expands it behind, propelling the vessel forward at speeds that defy conventional physics. Imagine folding a piece of paper. This simple analogy helps us grasp the concept of warp travel. Just as folding the paper brings two distant points together, the warp drive brings distant regions of space into close proximity. Two distant points suddenly become adjacent. This is the essence of warp travel, allowing us to bridge the vast gaps between stars in an instant. This, in essence, is the principle behind warp drive. By bending the fabric of space-time, we can achieve what was once thought impossible. The activation of the warp drive is a momentous event, marking the beginning of a journey that transcends the limitations of traditional propulsion methods. By bending the fabric of space-time, we bypass the limitations of traditional travel, opening up the cosmos to human exploration. This new era of space travel holds the promise of discovering new worlds, encountering alien civilizations, and expanding our understanding of the universe. The warp drive is not just a technological achievement, it is a gateway to the future of humanity's journey among the stars. Interstellar travel presents a unique set of challenges to the human body. The harsh conditions of space, from cosmic radiation to prolonged weightlessness, demand adaptation and innovation. To thrive beyond Earth, we must harness the power of bioengineering. Genetic modifications will enhance our resilience, making us less susceptible to the harmful effects of space travel. Advanced biosuits will regulate our internal environments, providing protection and ensuring our survival on alien worlds. Imagine a future where we can tailor our biology to thrive in a multitude of environments, adapting to the specific conditions of our destination. We will cultivate bioluminescent flora to illuminate our extraterrestrial habitats, and genetically engineered crops will provide sustenance in alien soil. Bioengineering, once a tool for healing, is now the key to our future among the stars. Section 4. A new home among the stars, terraforming alien worlds. As humanity looks to the stars, the dream of finding a new home becomes ever more tantalizing. The vast expanse of space holds countless planets, each with its own unique characteristics and potential. Finding a planet that perfectly mirrors Earth's delicate balance is a monumental task. The search involves analyzing countless data points, from atmospheric composition to gravitational forces, to identify worlds that could potentially support life. However, we are not limited to simply searching for habitable worlds. With advancements in technology, we have the capability to go beyond mere exploration. We can actively participate in the creation of new habitable environments. We now possess the technology to reshape them, to mold them to our needs. This involves deploying advanced machinery and robotic systems to construct the necessary infrastructure on these alien surfaces. This is the ambitious goal of terraforming. The process of transforming a planet's environment to make it suitable for human life is both complex and fascinating. It requires a deep understanding of planetary science and a commitment to long-term planning. Through a combination of advanced nanotechnology and climate engineering, we can transform barren planets into verdant oases. Imagine seeding an atmosphere with the right mix of gases to create a breathable environment, and using nanobots to alter the planet's surface at a microscopic level. Introducing genetically engineered microorganisms to enrich the soil is another crucial step. These microorganisms can help kickstart the growth of plant life, creating a foundation for a sustainable ecosystem. Diverting icy comets to replenish water sources is a dramatic but effective method. These comets, rich in water ice, can be redirected to crash into the planet, releasing their precious cargo and creating lakes, rivers, and oceans. Over time, these seemingly desolate worlds will bloom, transformed into vibrant ecosystems capable of supporting human life. The barren landscapes will give way to lush forests, flowing rivers, and diverse wildlife. Terraforming is a testament to human ingenuity, a bold declaration that we are not bound by the limitations of our home planet. It represents our ability to adapt and thrive in even the most challenging environments. It is a long and arduous process, but the rewards, a galaxy teeming with life and possibility, are well worth the effort. Imagine a future where humanity has spread across the stars, living on multiple terraformed planets, each with its own unique ecosystem and culture. This vision of the future is within our grasp, thanks to the incredible advancements in science and technology. Section 5: The Human Element, Psychological and Social Adaptations. The journey to the stars is not just a technological endeavor, it is also a profound human experience. The psychological and social challenges of interstellar travel are as daunting as the technical hurdles. Generational ships, colossal vessels carrying entire communities on journeys spanning centuries, will require novel social structures and cultural adaptations. Isolation, confinement, and the psychological effects of prolonged space travel will require innovative solutions. We will create immersive virtual environments to combat the monotony of interstellar journeys. Advanced communication systems will keep us connected to loved ones back on Earth, bridging the vast distances. Art, music, and literature will flourish in this new frontier, reflecting the unique experiences and perspectives of spacefaring civilizations. We will evolve, adapting not just physically to the challenges of space but also mentally and socially, forging a new identity. Is a future among the stars merely a science fiction fantasy? For centuries, humanity has gazed up at the night sky, wondering what lies beyond our home planet. The stars have inspired countless myths, legends, and dreams of exploration. But now, more than ever, the possibility of living among the stars is becoming a tangible reality. Or could it be our destiny? As we stand on the brink of a new era in space exploration, we must ask ourselves, what role will we play in this grand cosmic journey? The advancements in technology and the growing interest in space travel suggest that our destiny may indeed lie among the stars. The cosmos beckons, filled with countless stars and planets. Each celestial body holds the potential for discovery and wonder. From the swirling galaxies to the distant exoplanets, the universe is a vast playground waiting to be explored. The Hubble telescope has already given us glimpses of these distant worlds, sparking our imagination and fueling our desire to explore further. Could these distant worlds hold the key to humanity's survival and evolution? As Earth's resources become increasingly strained, the search for habitable planets becomes more urgent. These alien landscapes, with their unique environments and potential resources, could offer new opportunities for human settlement and growth. The discovery of exoplanets in distant solar systems has opened up a new frontier for exploration and the possibility of finding a new home for humanity. The answers lie not only in technological advancements but also within ourselves. Our ability to adapt, innovate, and collaborate will be crucial in overcoming the challenges of space exploration. The development of advanced space technology, from powerful rockets to sophisticated life support systems, is only part of the equation. Equally important, is our willingness to work together, share knowledge, and support one another in this ambitious endeavor. The pursuit of space exploration is a testament to human curiosity. Our innate desire to explore the unknown drives us to push boundaries and seek out new frontiers. The sight of a space shuttle launching into the sky, the image of astronauts floating in the vastness of space, and the dedicated efforts of mission control teams all symbolize our relentless quest for knowledge and adventure. Our innate desire to explore the unknown drives us to push boundaries. From the first steps on the moon to the deployment of deep space probes and rovers on Mars, each milestone in space exploration represents a leap forward in our understanding of the universe. These achievements are a testament to our determination and resilience in the face of the unknown. This same spirit of exploration will be essential as we venture further into the cosmos. The journey to distant stars and planets will require not only advanced technology but also the courage to face the unknown. As we build futuristic space stations and conduct experiments in microgravity, we are laying the groundwork for future generations to continue this grand adventure. It will require courage, ingenuity, and a collective will to succeed. The training of astronauts, the meticulous construction of spacecraft, and the careful planning of space missions all demonstrate the dedication and effort needed to achieve our goals. Each step forward is a testament to human ingenuity and the power of collaboration. But the question remains, will humanity rise to the occasion? Will we embrace the challenges and opportunities that lie ahead? The rocket launch sequences, the preparations of astronauts, and the inspirational imagery of space all serve as reminders of what we can achieve when we set our sights on the stars. Will we harness our collective knowledge and resources to make this interstellar odyssey a reality? The collaboration between international space agencies, the meetings of scientists and engineers, and the development of innovative space technology all point to a future where humanity works together to achieve a common goal. The pooling of our collective knowledge and resources will be essential in making this dream a reality. The next century will be pivotal. The choices we make today will shape the future of humanity for generations to come. The development of futuristic space settlements, the timeline of space missions, and the advancements in space technology all indicate that we are on the cusp of a new era. The decisions we make now will determine whether we become a multi-planetary species or remain confined to our home planet. The choices we make today will shape the future of humanity for generations to come. As we look up at the night sky, we are reminded of the endless possibilities that await us. The concept of space colonies, the wonder in the eyes of children gazing at the stars, and the diverse group of people united in their curiosity all symbolize the potential for a brighter future. It is up to us to seize this opportunity and chart a course for the stars. Our celestial neighbor Mars has long captivated our imagination. For centuries, humans have gazed at the night sky, wondering about the mysteries of the red planet. Its striking appearance and proximity to Earth have made it a focal point of both scientific inquiry and popular culture. From ancient mythology to modern science fiction, Mars has been a symbol of adventure and the unknown. Its rusty red surface hints at a past perhaps more Earth-like than it is today. Scientists believe that Mars once had liquid water, a thicker atmosphere, and possibly even life. The valleys and craters we see today are remnants of a dynamic history, shaped by volcanic activity, meteor impacts, and perhaps even ancient rivers and lakes. Establishing a permanent human presence on Mars is a crucial first step in our journey beyond Earth. This endeavor will not only test our technological capabilities, but also our resilience and adaptability. Living on Mars will require us to create self-sustaining habitats, grow food in a hostile environment, and protect ourselves from radiation and extreme temperatures. It will serve as a testing ground, allowing us to develop and refine the technologies and strategies needed for interstellar travel. The lessons we learn on Mars will be invaluable for future missions to more distant worlds. From advanced robotics to life support systems, the innovations developed for Mars exploration will pave the way for humanity's expansion into the cosmos. But Mars is just the beginning. Our ambitions extend far beyond the red planet. As we look to the stars, we see a universe teeming with possibilities. Each new discovery fuels our desire to explore further, to push the boundaries of what we know and what we can achieve. Beyond our solar system lie countless other stars. Each one is a potential gateway to new worlds and new opportunities. The Milky Way alone contains billions of stars, many of which are orbited by planets. These distant suns and their planetary systems are the next frontier in our quest to understand the universe. Many of these stars are orbited by planets, some of which might harbor conditions suitable for life. These exoplanets, as they are called, come in a variety of sizes and compositions. Some are rocky like Earth, while others are gas giants or icy worlds. The search for exoplanets has revealed a staggering diversity of planetary systems, each with its own unique characteristics. These exoplanets, as they are called, represent a vast frontier of exploration. With advanced telescopes and space probes, we are beginning to uncover the secrets of these distant worlds. By studying their atmospheres, climates, and potential for habitability, we hope to find clues about the origins of life and the potential for life beyond Earth. They offer the potential for new discoveries, new resources, and perhaps even new forms of life. Imagine landing on an alien world, exploring its landscapes, and uncovering its mysteries. The resources found on these planets could support future colonies and fuel further exploration. And the discovery of extraterrestrial life, even in its simplest forms, would be one of the most profound scientific achievements in human history. Imagine a future where humanity becomes an interstellar species. We could build cities on distant planets, create new societies, and expand our civilization across the galaxy. This vision of the future is not just a dream, it is a goal that drives our scientific and technological advancements. We could establish outposts on distant moons, mine asteroids for resources, and develop new industries in space. The asteroid belt alone contains vast amounts of minerals and metals that could be used to build spacecraft, habitats, and other infrastructure. By harnessing these resources, we can reduce our dependence on Earth and create a sustainable presence in space, and perhaps even encounter other intelligent life. The search for extraterrestrial intelligence, SETI, is one of the most exciting and challenging endeavors in science. By listening for signals from other civilizations, we hope to make contact with beings who share our curiosity and desire to explore the universe. The possibilities are truly limitless. As we venture into the cosmos, we are limited only by our imagination and our determination. The journey to Mars and beyond is a testament to the human spirit, a celebration of our quest for knowledge, and a promise of a future where we are no longer confined to a single planet, but are free to explore the infinite wonders of the universe. The vast distances between stars present a formidable challenge. The sheer scale of the universe is mind-boggling, with light taking years, decades, or even centuries to travel from one star to another. This immense distance makes interstellar travel one of the most daunting tasks humanity has ever faced. Traditional propulsion systems, like those used for rockets today, would take tens of thousands of years to reach even the nearest stars. These chemical rockets, while revolutionary in their own right, are simply not efficient enough for the grand scale of interstellar voyages. The limitations of current technology mean that we need to think far beyond our existing capabilities. To overcome this obstacle, we need breakthroughs in propulsion technology. The future of space travel hinges on our ability to innovate and develop new methods of propulsion that can drastically reduce travel time. This requires not just incremental improvements, but radical advancements that can change the very nature of how we traverse the cosmos. Scientists are actively exploring various concepts, including fusion propulsion, antimatter engines, and even theoretical warp drives. Each of these technologies offers a unique approach to solving the problem of interstellar travel. Fusion propulsion, for instance, aims to harness the power of nuclear fusion, the same process that powers our sun, to create a continuous and powerful thrust. Fusion power, the same energy source that powers the stars, holds immense potential. By replicating the fusion process in a controlled environment, we could generate vast amounts of energy, far surpassing what chemical rockets can produce. This energy could then be used to propel spacecraft at unprecedented speeds, making interstellar travel more feasible. It could provide the sustained thrust needed for interstellar journeys. Unlike traditional rockets that burn fuel in short bursts, a fusion-powered spacecraft could maintain a steady acceleration over long periods, gradually building up to incredible velocities. This sustained thrust is crucial for covering the vast distances between stars. Antimatter, with its incredible energy density, is another avenue of exploration. When matter and antimatter collide, they annihilate each other, releasing energy in the process. This reaction is far more efficient than any chemical reaction, offering the potential for propulsion systems that are orders of magnitude more powerful than anything we have today. And then there's the tantalizing possibility of warp drives, which would allow us to bend space-time itself, effectively creating shortcuts across vast cosmic distances. The concept of a warp drive, popularized by science fiction, involves creating a bubble of warped space around a spacecraft, allowing it to move faster than light without violating the laws of physics. These technologies may seem like science fiction today, but so did landing on the moon a century ago. The history of space exploration is filled with achievements that once seemed impossible. From the first artificial satellite to the moon landing, humanity has consistently pushed the boundaries of what is possible. With continued investment in research and development, what seems impossible today could become the reality of tomorrow. The quest for interstellar travel is not just about reaching distant stars, it's about expanding our horizons, pushing the limits of human ingenuity, and exploring the unknown. As we continue to innovate and explore, the dream of interstellar travel moves closer to becoming a reality. Interstellar travel presents unique challenges not only for our technology but also for our minds and bodies. Long-duration space travel can have profound psychological and physiological effects. The isolation, confinement, and lack of familiar sensory input can take a toll on even the most resilient individuals. Addressing these challenges is crucial for the well-being of future space travelers. Designing spacecraft with artificial gravity, providing access to natural light, and incorporating psychological support systems will be essential. We need to create environments that foster both physical health and mental well-being. Moreover, the ethical implications of interstellar travel are profound. What are our responsibilities to any life we might encounter on other planets? How do we ensure that our presence does not inadvertently harm existing ecosystems? These are questions that we must